Hey guys, how you doing? It's Coach Scott. Let's move on and let's start talking about molar volume. If I can get the slide to move. There we go. So, we're talking about gases more or less right now. And this here are just things that we know. The volume of a gas will vary with temperature and pressure. And we'll talk about that in Marchish sometimes. All right. But we can compare gases if we designate a standard temperature and pressure, and we can learn from them by just keeping those the same. We call it the standard temperature and pressure. Standard temperature is 0 degrees C or 273 degrees Kelvin, and that's where water freezes. Okay. Standard pressure is 1 atmosphere or 101.3 kilopascals. All right, and that's the pressure of the atmosphere at sea level, and we're almost at sea level here in Memphis. So we can make this statement: at STP, standard temperature and pressure, 1 mole of any gas will occupy a volume of 22.4 liters, or about 5 2-liter bottles. Okay, so we call that V sub M. Molar volume is 22.4. So for the most part, for a while, we're going to treat all gases that they're at STP. So the volume occupied by 1 mole of gas is what we call the molar volume. We just said that. And it's V sub M. It doesn't matter what the gas is. The molar volume is always going to be 22.4 liters. All right. So at STP, 1 mole of gas is going to equal 6.02 times 10 to the 23rd particles, whatever they are. And that's going to be 22.4 liters. It doesn't depend on what type of gas it is. It's gas. It just is. So, why is this true? It's true because in a gas, the molecules are so far apart that they take up almost no space. So the volume of the gas is mostly empty space, regardless of the type of gas. All right. So when it comes to volume at STP, gases are all equal. So 1 mole of helium gas occupies 22.4 liters at STP. 1 mole of hydrochloric gas, hydrogen chloride gas, occupies 22.4 liters at STP. So which of the following must be true about 2 moles of hydrogen gas versus 2 moles of carbon dioxide gas at the same temperature and pressure? They'll have the same density? No, they're going to have different masses. There'll be the same number of atoms will be present in each sample. Not the same number of atoms, right? Because there's 3 atoms in carbon dioxide and there's 2 atoms in H2, hydrogen. Each sample will have the same mass? No, that's not true. But each sample will occupy the same volume. So at STP, 1 mole, or 6.02 times 10 to the 23rd particles of any gas occupies a volume of 22.4 liters. So now we can write a relationship, a ratio, a proportion. We call the 22.4 liter, right, the molar volume of gas, V sub M. So we can say N, or the number of moles of gas, is equal to the volume of the sample divided by the molar volume, all right, of 22.4. So how many moles are there in 44.8 liters at STP of fluorine gas? So we're trying to find N. We've got 44.8 liters. So I'm going to use my little formula here. Let me get it. All right. I'm going to get 22.4. Let's see if I can write with this. I don't know N. Don't know N. I know my volume, 44.8 liters. That's my sample volume. And I know V sub M. because it's always 22.4 liters per mole. So the number of moles is going to be 484.8 divided by 22.4, or 2 moles. Easy peasy, not hard. Okay, so Jose, what's the volume in liters of 1 mole of sulfur dioxide? It's got to be 22.4, because 1 mole of any gas at STP is 22.4. So that's C. Now, that formula looked pretty similar to the others we were looking at, and they are. So now we've got 3 formulas that we can use to find the number of moles of a substance. Okay. Now, which one do we use depends on what we're trying to find or what you're given. If we're given the number of particles, it's little n equal big N, the number of particles, divided by Avogadro's number. If we're looking for the mass of a substance, or we're given the mass of a substance, okay, the N, the number of moles, is equal to the sample mass divided by the molar mass. And for volume, N, the number of moles, is equal to the sample volume divided by the molar volume. Very similar. Now, sometimes we're asked or we're given some unknowns, and we've got to use 2 of these formulas to solve a problem. Here's an example. How many atoms of carbon are present in a 24-gram sample of pure carbon? So I'm given grams, right? All right, grams. So I know I've got to go here. All right. And it's asking for atoms. So then I'm going to have to use this one also. This one first to find N, and then this one. Okay. See how that works. So the number of moles, that's what we can do first. Find the number of moles of carbon present. Another little hint about the next 4 weeks, find moles first, always. So little n equal little m, sample size, 24 grams, divided by the molar mass from the periodic table. So N is equal to 24 divided by 12, which is 2 moles. So now we need to find the number of atoms in 2 moles. So we rearrange this in. We know Avogadro's number because it's given to us. We know little n, so we do our little algebraic manipulation. So that's going to be 2 times Avogadro's number, or 1.2 times 10 to the 24th. And I'll print this out for you. We could call this Mole Island, the Mole Roadmap. If you want to, I'll give you a couple of copies. But here, if you start with molar mass, or mass, this is how we convert to moles. If we start with volume, that's how we convert to moles. If we start with particles, that's how we convert to moles. Now, after we find moles, that's how we convert to volume. That's how we convert to particles. That's how we convert to mass. So this is a nice little tool if you want to use that. Another couple of samples, we're almost done. How many molecules are there in 44.8 liters at STP of oxygen gas? So I've got volume. Let's go back there. And it's asking for molecules or particles. So I've got volume. So I need to find moles. Then I need to find particles, molecules. So we're going to use that formula and that formula. Let's go back here and do our thing. Okay. So going back over here, I've got 44.8 liters at STP. So I'm going to use N equal V over V sub M. There's my V sub M. So I'm going to have 44.8 divided by 22.4 liters. That's going to give me an N of 2. So it's asking for the number of particles of 2 moles. So now I do this. I know my N, 2, and I'm going to use this number. So 2 moles divided by, I don't know the number of molecules, divided by Avogadro's number, 6.02 times 10 to the 23rd. Molecules per mole. All right, so I do my little math. Okay, and I'm going to multiply this times 2. I'm going to come up with what? 1.2. If I do my math, it's going to be 2 times 6.02 times 10 to the 23rd. And it's going to be D. And it is. Okay, guys. So we got lots of these we're going to work on in class. Okay. I'll print out the mole roadmap for you, but to me, volume is one of the easier ones of gas. 22.4 per mole. Okay. Well, anyway, this is Coach Scott saying have a great day, and I'll see you on the flip side. Bye for now.